this video we're just going to go through 4 easy tips for finding stationary points for graphs, and then do a couple of examples to demonstrate the point. If you are new to this channel, this is the first video you've seen, please subscribe. All your support's appreciated. And now into the tips. The first tip is to rearrange or write the equation in the form y equals f of x, and this could be y equals f of x, or s as a function of t, as we'll see later, or q as a function of r. But the point is, we want to have one expressed entirely in terms of another, because this makes it easier to differentiate. And if you're watching this video and you want to know how to find stationary points, you're at a level of maths where you can only differentiate with respect to one variable, so it's key to rearrange it like this. If it's impossible to rearrange it like this, we have to use something called implicit differentiation, which there will be videos on linked somewhere, but for now we just want to try rearrange it into this form, because this will make it easier for us. Second tip is to differentiate. You want to differentiate with respect to whatever this variable is here in the brackets, alright? Tip is, well, no, it's not tip, steps, right, is to solve for dy by dx equals 0. This will give us all the x coordinates that are our stationary points, right? So give us all the x values where our gradient equals 0, and when the gradient is equal to 0, dy by dx equals 0. This is our definition of a stationary point. So this was clearly one of the steps. Comes in at step 3. And then finally, we want to substitute these values of x, so the solutions to this equation here, we want to put them in to our function here to output some y, and then we'll have our x and y, and these are stationary points. And we could have one of these, two of these, three of these, whatever. So here you make sure to find all the solutions. But now we'll get on with some examples to help demonstrate some of the points made here. So for this first example, it's step 1's already been completed. It's already in the desired form. It's in the form y is equal to a function of x. So step 2 was to differentiate with respect to x. So dy by dx is equal to 2x 4. And now we want to set dy by dx equal to 0. So this leads to that 2x is equal to minus 4, which gives us the x is equal to minus 2. So that's step 2 completed. Finally, step 4. So our y's equal to minus 2 squared plus 4 multiplied by minus 2 minus 8 plus 1, and that's equal to minus 3. So our single stationary point is minus 2 minus 3. We don't have any others because this clearly has no more real solutions. So that was a pretty simple example. We'll do one more for today's video. In this next example, we don't have the desired form. We have on the right hand side a function of e and s. So we're just going to add s to both sides so that we've got it in the form s is a function of t and now we're going to differentiate with respect to t. So this gives us ds by dt is equal to 3t squared minus 12t plus 9. Just note all the examples I've done in this video have just been polynomial differentiation, which is relatively simple. I'm assuming you can do this. If you do need some help with this, then be sure to comment below, or if you want to see me differentiate more complicated functions to find stationary points, I can definitely do that. So now we're going to set this equal to 0. So this then implies, if you can see, all these have a factor of 3 in them, and since 3 cannot be equal to 0, we can divide both sides of the equation, and the equation is 3t squared minus 12t plus 9 is equal to 0. We can divide by 3, which gives us that t squared minus 4t plus 3 is equal to 0, which is a little bit easier to solve. And then factorising this, you get t minus 3, t minus 1 is equal to 0, and t equal to 1 is our t coordinate. Substituting this in, when t is equal to 3, we get s is equal to 0, and we can just check that. So t cubed is 27, right, plus another 27, that's 54, and then we have t squared is 9 times by 6 is 54, this is subtracted, so that is 0, and then when we put t in as 1, we get s is equal to 4, and that's from, you got 1 plus 10, plus 9, that's 10, minus x, so that's 4. So these are our solution pairs, our sets of coordinates essentially. Yeah, that's it for this video. We'll do much more on the basics of calculus. This comes in at sort of an early A level, so if you've just started your A levels, the sort of stuff that you can expect to be doing does come up on exams. You can also get examples where, I don't know, t might be raised to a fractional power. You just do the same thing, but you just got to be comfortable multiplying by fractions and making negatives and making sure you keep your arithmetic nice and tight, which can be irritating and messes up all your solutions. And if you're doing this as part of a much larger problem where maybe you have to classify these stationary points, or you have to draw a graph or something once you got them, or it's part of a larger problem solving thing, it can really mess you up. So every line of arithmetic you do, and it's certainly a habit that it's hard to keep up, but you do a line, check the line before you go on to the next line. Don't do 3-4 lines of working out, then realise that you've messed up here, because once you've messed up here, everything else becomes wrong, because you get that right, you can just keep going nice and steadily. So yeah, that's it for this video. I hope you enjoyed it. If you did find it useful, please like and subscribe. Comment down below what sort of videos you'd like to see. But for now, that's it. I hope to see you in the next one.